Today's lesson is over map projections. A map projection is any method used in cartography to represent the curved surface of the Earth on a flat surface. This cannot be done without some distortion. The mapmaker must select the one best suited to the needs, reducing distortion of the most important features. A distortion is a loss of accuracy in the size or position of objects on a map. This can make things appear too large, too small, or out of place. Map makers and mathematicians have devised almost limitless ways to project the image of the globe onto paper. Every projection has its own set of advantages and disadvantages. There is no perfect map projection. Good uses of flat maps. Flat maps can be more useful than globes in many situations. Maps are more compact and easier to store. They are viewed easily on computer displays. Maps can show larger portions of the Earth's surface at once. These useful traits of flat maps motivate the development of map projections. The problem with flat maps. Every flat map misrepresents the surface of the Earth in some way. No map can rival a globe in truly representing the surface of the entire Earth. Since the world is a sphere and a globe is a sphere, a perfect representation can be made. The Mercator projection. This map makes areas near the poles look bigger than they really are. Example, Greenland looks bigger than it really is. Here, it is larger than South America, but in real life it is less than half the size. This is because on a globe the lines of longitude meet at the poles, but on this type they are parallels. Here's an example of how objects can appear distorted on map projections. You'll notice some of these projections look fairly normal. However, in the very last figure, figure 45, would be an example of the Mercator projection. As earlier stated, the Mercator projection shows distortion closer to the poles, in this case, the tops and the bottom of this map. Let's compare these two map projections. The projection on the left is taken from the underside of the Earth. It shows Antarctica in its completion. The Mercator projection on the right shows Antarctica is much larger than any other landmass on Earth. This is because the Mercator, as earlier stated, shows distortion closer to the poles, in this case, the South Pole. Interrupted projection. By creating gaps in the picture of the world, mapmakers showed the size and the shape most of the land quite accurately. Problems. The gaps make it impossible to figure distances correctly. You could not use this kind of map to chart a journey across the ocean. The Peters projection. The Peters projection was created in 1974 by Dr. Arno Peters to address some of the distortions of existing maps. The problem with this one is that 1 square inch anywhere on this map represents an equal number of square miles. This distorts the shape in some cases, for example, Africa. The Robinson projection. Presented by Dr. Arthur H. Robinson in 1963. Today, many geographers believe this to be the best world map available. It has been called so by National Geographic. While the Robinson projection does distort the globe a little, for example, Antarctica, it shows most sizes and shapes of the countries accurately. Conclusion. There are many other types of projections, each with positives and negatives about them. The key is knowing for what purpose you wish to use the map. You will then be able to pick the map that best suits your needs. The next 3 slides are questions regarding the PowerPoint. Question 1. Which map projection do most geographers and the National Geographic believe to be the most accurate? A. Mercator, B. Interrupted, C. Peters, or D. Robinson? Question 2. Which map projection makes finding distance difficult due to gaps in the map? A. Mercator, B. Interrupted, C. Peters, or D. Robinson? Question 3. Which map projection shows distortion by making objects appear larger than they are towards the poles? A. Mercator, B. Interrupted, C. Peters, or D. Robinson?